Part 2 of Lesson 5.2, Graphing Quadratics from the Standard Form. We're going to start off with not graphing, but converting from vertex form to standard form, and later you'll learn how to go the other direction. Right, so we have f of x is equal to x plus 2 squared minus 4. Now something squared means times itself, so we're going to make it x plus 2 times x plus 2, and then we're going to have the minus 4. Now over here I've got this box. What I'm going to do with the box is I'm going to show you the distribution or the double distribution. So I'm going to put an x here to represent this length and a 2 there. It doesn't matter if x turns out to be bigger than the 2. This is just a graphic. It just helps to organize it. So here it's going to be the answer to x times x, which is x squared, and here 2 times x. And here's another 2 times x in this box. And this is 2 times 2. Now in the diagonal, we are going to have like terms to combine, so I've got 2x plus 2x. So I get x squared plus 2x is plus 4x, then plus 4. Now that was from just this much, which was this. I still have that minus 4, so I'll bring that down. And I have plus 4 minus 4, so that's 0. So I'm going to bring down the f of x. And then simplify. The plus 4 and the minus 4 become 0. We don't need to write that. Add 0 is, well, nothing. So f of x is equal to x squared plus 4x. And that's it. Alright, next one will be a little bit more complicated because I've got an a value that's not 1. It's going to hang out and it's going to wait for the result of the x minus 1 squared. I'm going to change my pen to red for all of the x minus 1 squared. So the x minus 1 squared, something times itself. I'm going to write the x's here and the negative 1 here and there. X minus 1, but separated, it's going to look like an x and a negative 1. X squared for this box minus x plus 1. I could have just written a 1, but plus 1 because a negative times a negative is a positive. In this diagonal, like terms combine. So this x minus 1 quantity squared simplifies to be x squared minus 2x plus 1. Now everything else, that a value and the c value come into play. I now distribute the a value to all three of these terms. So I'm going to get negative 3x squared plus 6x minus 3. And then now bring down the c, add 4, and I got one more like term to simplify. Negative 3 plus 4 is plus 1, so negative 3x squared plus 6x plus 1. And I can bring down my y, and we're all set with that. So this little graphic should be helpful. I don't know if you've seen it before in previous classes. Not everybody uses it. I just lost power, so all the work that you saw there is gone, but that's okay. I got it happened in an opportune time. What I was about to say was the x minus 1 squared you might have seen by other names, and so I wanted to, or other methods, and I wanted to go through those. So maybe you saw or heard of FOIL, first, outside, inside, last, where the first would be the x times the x. The outside would be the x times the negative 1. The inside would be negative 1 times x. And last would be negative 1 times negative 1. So, same deal as this graphic. It's also called double distribution, smiley method. I like the smiley method. Sometimes people don't see the smile. But how about now? So if I replace the x minus 1s with those little dots, yeah, I get a little smile there. And The eyebrows are up here, or hair, or whatever. So anyhow, there's a number of different method names for what's happening with the x minus 1, but I've found this graphic to be really helpful for review, or for people just learning it. Okay, moving on. So a application problem. So this futuristic robot is going to hit a fly ball really, really high. It's going to follow this equation, and we are going to find its highest point. So basically, we are going to find the y value at the vertex. So we do x equals negative b over 2a, which is going to be negative 200 over 2 times negative 1. A is negative 1. You don't see the 1, but it's a negative out there. What would it be if it wasn't a negative 1? It's not a 0, or the x squared would be gone. So I have a negative divided by a negative, so that's a positive, and I have 200 divided by 2, so that's 100. So x is 100, so we're going to find f of x, or f of 100, and we will have our answer. Negative. Now, in previous problems, but I dare not go back, I'm sure it was erased by the power outage, but we had a negative as an input and it got squared. That is not happening here. The power only affects the symbol immediately to the left of it, unless it's a grouping symbol like a parenthesis or an absolute value or other grouping symbols. So this negative 1 right here is going to multiply the 100 after it gets squared. Then plus 200 times 100, and then minus the 8,500, and I'm running out of room. 100 times 100, that's going to be 10,000. Multiply by a negative 1, and it's negative 10,000. 200 times 100, this is easy. If I'm not using a calculator, I just do 2 times 1 is 2, and then I have 1, 2, 3, 4 zeros. If you didn't know that trick, it comes in handy. And this was just 100 times 100, so I'm just visualizing this, except for there's a 1 there. And then I'll deal with this in a second. So I've got 20,000 minus 10,000, and that's 10,000. Minus 8,500 is 1,500. So this robot baseball player hits the ball 1,500 feet up into the air. Okay, you try it. This is what I got so far. So here's what I have for a vertex so far, and that's up here at 10, and my graph only goes up to 7. Now, I could have made my scale different, but I don't want to. A value over 1, down 1. No, not down 1, down 2, because it's 2a. So that's going to be about there, and then, let's see, 1, 3, 5 becomes 2, 6, 10. So over 1 and down 6, that would be like down 5 from here. 1, 2, 3, 4, 5. Reflect. And I have almost enough room to go down 10. Try it. Here's what I got so far. If you did not get the correct x value for your axis of symmetry, you might want to pick it up again. And here's what I have. Not our easiest calculation today. We had a negative times a negative in the numerator, which made it a positive. We have a negative times a positive in the denominator, which made it a negative. And unlike most of our fractions in the denominator, this one wasn't that friendly. 7 divided by a half is 14. Positive divided by negative is a negative, and plugging it in, well, a calculator probably came in handy. We did have some nice things, like this went evenly, this became 100, so ultimately 51 is our answer, and it is a maximum value because this parabola has a negative a, so that means that it tops out. So the answer is it's a max, and it is 51.